Welcome back to this series on how to create digital guitar pedals. Here is what we are going to have by the end of this video. Yeah, it's a mess, but at least it works. We are doing everything on a Raspberry Pi, but as mentioned in the previous video, you don't have to. You actually can use a regular PC, either Linux, ideally, or Windows. If you have any question regarding that or something else, please ask me in the comments. The goal of this video is to take the audio from your audio interface, get it in your C++ code, modifying it, for example, Fuzz, and then getting it out. It's what we are going to do, and for that we are going to use a sound or audio input-output library called PortAudio, which is here. I've been using this for my own audio pedal and it's working really well. And they also have some audio example programs which are going to be really convenient for us, because one of them is a guitar fuzz. Basically, you download the library, you compile it, you run the program, and boom, you already have a fuzz pedal. Of course, we will make some modifications to that to make it easily changeable, the parameters, and also add some delay. And in the next video, we will add some physical buttons or rotary encoders to actually physically be able to change the parameters of those audio effects. But for now, let's stick to the compiling the library. First thing first, when you have a new library, it will be to open the documentation. It's what we are going to do, and for now we only need the tutorial, but the API reference could be useful for you in the future, so you probably should keep that somewhere. Here we are seeing three things, Windows, Mac, and Linux. If you are not using a Raspberry Pi, this may be interesting for you, so I will let you have a look at that. But interesting point here is ASIO. If you already recorded yourself on Windows with an audio interface, you might be aware of that. ASIO is a real-time audio server which allows you to reduce the latency of when you play the guitar and try to record it and directly play it back. So you will need that on Windows, and for us on Linux we will need something called jackd, which is a direct equivalent of ASIO. So let's click Linux, and we don't see much about jackd here, so we will actually install it ourselves. So here I'm back in some SSH view, and I'm going to install two packages. First is jackd, and second one jackd2 dev. Here you can see it. It's basically the jackd libraries for development. Since we are going to compile PortAudio, we actually need that one, and we need to install it before compiling PortAudio. It's really important. Okay, click yes, and it's installed. Here you can see something about QJack control. It's basically a tool which we can try to start, but it won't work in your SSH view because you need a X display or a X environment to run it. You could SSH X forward, but for now we are not going to do that. So open your VNC view and type again QJack control, and now you can see it works because you are doing this from a Windows view environment. You click setup, and here's the default setup for Jack. You can pick your interface. It will probably be the third one, because the two first ones are actually the default chipset of your Raspberry Pi. So for me it would be this one. It might be the same name for you, or maybe not, but probably USB something. Also the sample rate. Check your sound card. For me it's 44100. For instance, if you are using a professional recording USB interface, it probably would be 192, but you should probably check it and remember the number. And then the frame per buffer, it will have some effect on the latency, and for now we are going to use 128, and then again just remember which number you are going to use. Now you may notice a small problem. The default resolution of the Raspberry Pi is too small, and we cannot really click OK. So if you have this, full screen your VNC, hold the Alt key, click anywhere and drag. On Linux, it's a way to move the windows without having to click the title bar. Now you can click OK, and then start. Jack is started, we don't need VNC anymore. Now we can go back on our terminal. No, actually on PortAudio. We can follow the instruction for building PortAudio, but first we need to clone the sources. So you go to Git repo, then the Git repository is here. Git is basically a tool used by every developer for code versioning. So you can copy this link here and then go to your terminal, type git clone, then the URL. If you don't have the git command installed, normally it's the case on Raspberry Pi OS, but if for some reason you don't have it, you can just type this and then it will work. But for us it's good and it's clone, and we now have access to the sources of PortAudio. What they are telling us next in the documentation is to install some libraries. So we are going to do it. Okay, so it's good, it should be working. And then next step would be to configure and make, which actually will build the program. We are starting with config. Okay, important thing here, as you can see here and here, we have Jack yes. It means that Jack have been included in the built-in libraries of PortAudio, and you need that. That's why we needed to install Jack before compiling PortAudio. So if you have a no here, well, there is a problem you need to fix. And now we can actually make the libraries. So now it is compiling the sources of PortAudio. Perfect, it's done. Now if you look at the files, we see a couple new folders, such as bins and lib. First we are going to visit bin. Here, basically, it's executable binaries. On Windows, it will have been .exe, for example, but we don't have any extensions on Linux. So we are going to exec the PIA devices, and what we can see here is this line for device 1, which is default jack inputs and default jack outputs. It's because of the thing we did on the VNC here. If you stop your jack server, you don't have this line. But now, two things to remember, maybe three even: the number of this device, the max input, and the max output. Depending on your sound card, it could be 1 and 2, 2 and 2, or maybe even 4 and 4 if you are using some good audio interface for recording. And now we can try running the Fuzz example, but it won't work because, as you can see, no default input channel. And indeed, when we look at our devices, we do have a default jack input, but we don't have a default input. For that, we are going to modify the code. And we need to go back to PortAudio and actually install the libraries. Because for now, we compiled the example, but we haven't installed the libraries. As you can see here, we need to do this command. Now, our PortAudio libraries have been installed in our user local libraries, which work for anyone on this Raspberry Pi. As they are mentioning here, it's not so portable because it's actually installed on your computer. So if you are maybe using another Raspberry Pi, it won't work anymore. It could work, it could be good, but for now it's not what we are going to do. We are going to copy this library here to examples. So here we are copying the libPortAudio static libraries to examples. And if we go to the folders example, we can see that indeed we now have a libPortAudio.a to the example folder. So it's really what we need for now for the rest. Which means that we can now run this line to compile one of the programs. We are starting to compile the PA devs, and we need to indicate the padevs.c source file, and this is the output, and we are naming our binary devs. Okay, it's good. And if we run devs, we have exactly the same output as we had in the previous time we rerun it. It's perfect. We can try now compiling the Fuzz. Okay, it works. And what if we run it? And then again, it doesn't work. So what we need to do now is actually modify the PA Fuzz to select one input device. I'm going to do something different. I'm going to use another Raspberry Pi because this other Raspberry Pi is already linked to my audio interface, so it will be more convenient for me. Here's the one I've been using for trying with you, and here is it. But those are configured basically the same way. But there is still a tiny difference which could actually happen to you. Here I'm running device on my other Raspberry Pi, and as you can see I have a lot of them, and default jack input and output is actually device 7. So I will use the number 7, but you probably will have to use the number 1. And another big difference, which could be very important for you, is max input equal 1. In this sound audio interface, I had stereo input and stereo output. But on this one, I only have mono input and stereo output. And if you are using something else, you might have 4 input and 4 output. So if you don't have 2 and 2, like me now, we will have to make a small change to our PA fuzz. So here is it. I just use another folder, but for you it's only this. And here we have PA fuzz. I'm just going to rename it for using C++ file extension. It will be more convenient for after. And now you can edit it. So if you remember the previous video, you have a couple of ways to do this, maybe using Visual Studio Code or maybe Vi yourself, or, well, you can edit it. If you have some question for that, you can ask me, of course. And first thing to modify is around line 52 will be the sample rate. For me, I'm using 44.1, so it's good, but if you are using 48 or maybe 192, you will need to change this. Also, we could keep 74 here, but it's still better to use the same value as the one we used in the jack configuration view here. So for me, it will be 128 and probably the same for you. Now let's go at the bottom of the file, and we have a few things to change. Here we are seeing output parameters channel count, stereo output indicated in comment. It's good because I actually have stereo output, as you can see here. There is also channel count for input parameters equal 2. It's not the case for me because I only use one input channel. If you have 1, you put 1. If you have 2, you put 2. If you have 4, you put 4. So let's use that. Second thing to modify would be the PA get default input device and output. If you remember, the message was there is no input device by default, and it's true, and we are not going to use this function but manually point the input and output device you are using. So for me it will be number 7, but for you it might be 1 or something else. So I'm going to put 7 here and 7 for output parameters the device as well. So here's the only thing we need to touch here for now. But if you are not using 2 inputs and 2 outputs, you are going to have, like me, another problem. Here I'm going to give more explanation about that later, but you can see that we have twice out and twice in. That's a problem. So for me, since I'm using only one input, I'm going to remove that in and put a 0, which means that I will not have audio in my right ear, but I'm recording in mono, so you won't hear it. But here is the fuzz, and I only have one input. So it's good for me. If you have 4, you should also put 4 of those, basically. And now we save, and we compile again. We run it again. And now this should work. As you can see, the sound is slightly fuzzed, and now we actually have everything working. If it's not the case for you, please ask me a question in the comments and we will solve this. But normally now we can go on to the second part of this video, which is how to make the fuzz better and how to add some delay on it. First thing we would like to do on our Raspberry Pi would be to change the volumes of the sound card. By this, open a terminal. You could do it in SSH or VNC and tap ALSA Mixer. It's basically to change the volumes of microphones and outputs. Click F6 to select a sound card and pick what would normally be the second one. And then click F5 to show everything. And now we can see something. The speaker is minus 20 decibels and the microphone is plus 20, which is normal because normally microphones are amplified. Normally, you would probably want everything to 0 because you are putting directly an instrument and not a normal microphone. But it may change depending on your sound card or anything, so you might want to try different things. And now we have everything to 0, so you can just click Escape and go back to this, and we are good for this step, and we can go to the next step.